Okay, so this is chapter 6 on series and sequences, and there's two big formulas that you guys need to memorize from this chapter. The arithmetic and geometric sequence. And it's really important that you guys know the difference between something's arithmetic and then when something's geometric. The difference is if it's arithmetic, you guys are adding from one term to the next. And here's your formula. It is something you need to memorize. So, and 1 plus n minus 1 times d. I didn't really have any good tricks for you guys with these, unfortunately. No songs. That's why I never remembered. Sorry. So, in here though, A1 is always the first term of the sequence. D is the common difference, it's what you add. Right. And then n is going to be the term you want to find. So, one thing though, if you have to find the nth term, do you remember what you keep n? N, good. Right. So, let's see what's going on in this problem. Right. Some of the stuff you guys will see looks something like this. And it's really important you guys identify what's going on first before you pick the formula. So, in here, what's going on between all of these? Good. Adding 2. So, as soon as you see adding, that means it has to be the arithmetic one. Okay. So, write it out. A(n) equals A1 plus n minus 1 times d. And we're going to sub in values. So, a sub 1 is your first term in the sequence, which is what? 10. Good. So, a sub 10 plus. Now, it just says the nth term, so n is going to stay n here. Yep. Minus 1. And then the d, common difference, was 2. Alright, be really careful when you simplify these because you have something on the outside of a parenthesis, it's just on the other side. So distribute it through. So 10 plus 2n minus 2. And then we want to combine the like term. You got it, thanks Andrew. E plus 2n. Super. Now we hit. So e plus 2n. How was that, Connor? A little bit with that? If they give you guys something like this, find the 10th term of a sequence. Yeah, you could kind of keep going and adding them and kind of seeing what's going to be the 10th term. But if it said what's like the 100th term, do you want to do that? No. So let's use our formula and kind of make sure we can figure out what's going on here. What are you adding each time? 2. Great. Okay. So again, since we're adding, it's got to be arithmetic. And we're adding 2 in here. So we're going to use our formula a(n) equals a1 plus n minus 1 times d. Right. What's your a1 going to be? 3. Good.
So 3 plus 10 minus 1.
Nice. Yeah. Good job. Now, if they give you the term you're looking for, the 10th term, that's going to be your n here. Good job. Yeah. And what's the d? 2. Perfect. All right. Okay. Now, since you don't have any letters left, you have to follow rules of PEMDAS. Right. Parentheses first. So 10 minus 1 is 9. Yep. Okay. Then we have to do 9 times 2, which is.
Mrs. Tobin, can you please call the main office, Mrs. Tobin?
All right. And then 18 plus 3. 21. Good job. Good work. So. Those aren't too bad. It's more like making sure you guys know your formula than anything. Right? I don't see a lot of this. The arithmetic series. What a series means is that you're taking all the terms and physically adding them together. I don't see a lot of this. Right? And if I do see it, you don't have to use the formula. I'll show you guys with the formula just so you know. But if they said find some of the first 15 terms of sequence, well, can you guys figure out what's going on in here? What are you doing? Adding 2. So if they asked you guys to figure out the first 15 terms and add them together, yeah, I would. If I did it with the formula and you did it just adding them up, you'll get done faster than I will. All right? I would just write it out and do it. Now, the problem with the formula is that if you guys try to use this, A1 plus A(n), all of them too, we get a little stuck. Now, the n, how many terms do we have here? 15. So if you were trying to use your formula, right, the a sub 1 would be 4. Do we know what the 15th term actually is?
No.
Not unless you actually wrote it out. So I don't know this part. So can you solve something when we have two unknowns? No. So the reason, if you guys were going to use this formula, it's kind of a pain in the butt. Because to get your a to the n, you have to actually use the arithmetic sequence formula. I know, it really is a pain in the butt. So now, we can figure out what that a to the n is by starting with this. Your a to 1 is 4. The n is going to be 15 minus 1, and the d was 2. So if you guys simplified all this stuff out, it's going to give you 14 times 2, which is 28. So first 32. Now that part is just the a to the n. So now, once you had this, you have to plug it back in to your original formula. Way up here. So I know that this now is 32. So we have 15 times, that's going to give us 36. Roll over 2. Right, that was 15 times divided by 2. 270? Yeah. 270? Now, those of you guys.
Could this be like a part 2?
Part 2 or part 1, yeah.
So if it's a part 1 that literally asks for 6, can you just count?
Yeah, and I would do that in part 2 too.
They usually ask for more.
Well,
if it's a part 2, like not like one, or even if you get the right answer and they still need to be
right, but you would have to show.
you just shout like plus 2.
Yeah, like you would have to show all the things that you were adding.
Okay, did you make that question up?
This one, no.
Is that on here? Like, is that on here?
Yeah, so you don't have it on.
No, I'm just confused which order we are.
Okay.
Did you do that?
Yeah, yeah.
Okay, we're doing it.
Yeah, that's right.
Sorry.
So that's okay. That's the other way you could do it. So if you
Okay.
physically added all those together, you're fine.
Okay.
But it took you way less time than it took me, right?
Right.
So, I mean, you don't have to use this formula. It's given to you, but you don't even need it, right? There's nothing stopping you guys as long as you show you all your terms, like you, and then add them together. That's kind of yellow.
So if you were to just like add them all together, would you still use like 3, 4, and 2, 11?
Yeah, exactly. Yep.
Or would you care if you had to do like
15
and
beyond.
then 15?
No, you count those in it. Good question. So the other thing was geometric, and the difference between the geometric and arithmetic was that geometric, you guys are multiplying. And the formula is 1, you have to memorize this one. Okay, a sub 1 is still going to be your first term in the sequence. The R is called the common ratio, it's what you multiply by. N is the term you're looking for. Just make sure this whole thing up here is an exponent. Okay, just watch out for that. Alright, so find the 7th term in the sequence. Well, let's see what's going on here.
Multiply like
By 3, good job, yeah. Times 10. Great. So as soon as we know we're multiplying, let's use our geometric formula. Okay. So it is a sub 1 times r to n minus 1. Okay, so what's your e sub 1 going to be in here? 2. Good. Right. The r is your common ratio, which is multiplying by 3. What term do you want?
7 minus 1.
7 minus 1, awesome. Good. Who's it, Ashlyn? That's it? Lily? No, that was good. Make sure you guys are careful with your PEMDAS or calculators, please get them. So reduce this. 7 minus 1 is just 6. Now, if you're going to type this in on your calculator, you need parentheses around the 3, right? If you put this up, you got to do the 3 to the 6 first, and then times it by 2. So, 2, 3, 6.
720.
Would you go?
Oh, I did the thing first.
Oh, now just times it.
Oh, it's like
Oh, by 2. Yep. There we go. Okay, good job. Anybody have issues putting it in
I
calculator?
just multiply by it.
That's okay. It's 1458. Good job. Next one's a little tricky. What is the formula for the nth term this one?
Oh, 4. It's 1.
It was just rejected or negative.
The toughest part here is to figure out what's going on. Because,
Oh, clearly it's 1/3.
well, I mean, if you look right here, I guess you can figure out, yeah, it's got to be 1/3. But this is tricky because let's say, I mean, you're decreasing, right? Usually when you multiply, you get bigger. Do you guys remember the little trick I showed you? If you pick one term and you divide by by what comes right before it, you get what you multiply by. So if you did 18 out of 54. That's okay, you did a great job. Right, and you use your math fraction key. You guys know what your math fraction key, right?
Yeah.
Okay, so 0.3 repeating is really 1/3. So that's another way you guys can tell like what you multiply by. Or if anybody noticed that you were dividing by 3, right? Division is really the same as like, remember copy, change, flip? Where we change that to multiplication, we flip the second fraction. So that's why dividing by 3 is the same thing as multiplying by 1/3. Which one did you guys think it was? 4. 4? Good job. It's 4. It's 4. Just be careful you're not getting tricked with the formulas, because they'll try to like make things look the same. Yeah.
Yeah.
Like you divide by the number of that order. So like you do 6. Well, no, I just look at it.
Oh, I can do it.
You walk from home? When they drop you off? It's hot outside. You might have to give it a second to have the fucking car cool down there, because it may be 1,000 degrees.
But I can use it on Wi-Fi right there. Yeah. So when I get home, I'll be fine.
Right.
What are you talking about?
My mom turned off my dad. I think I used it all in like the first.
Really? For some reason, the iPhone 6 decides to eat data. So I'm at 3 gigs and I still have 22 gigs
Yeah, I've
left.
used 30 gigs like 3 times.
Alright,
I only have 6 gigs.
Okay. Use your big talk. Okay. Now in this one, they're asking you guys, what would the sum of all these be? Again, if you guys get something about adding the whole thing together, it's serious stuff. You get this on the reference sheet, but it's much easier just to physically do it. So if you were going to keep going, and you wanted your n to be 10, you wanted 10 terms, can you guys just keep going with this? Yeah. Right. It's going to get long. It is a pain in the butt. Now, if you want to use this, though, we can. So if you were going to use your formula, right, what's your A1, you think? 1, good. And then we have 1 minus. What's your ratio? What do you guys do each time? Good, so you times it by 5. Good job. Right, so it's going to be 5. Now your n is going to be 10. Oh, actually, it's not that bad to do this with. Alright, so we have 1 minus your r was 5. Do we know everything is here? Yeah, this is nice. We don't have any extra stuff. So it's just a lot more work. We can simplify some of these. -4. Make sure we're doing 10 down. 5 to the 10, which is 1 minus that. And the calculator would work. Would be awesome.
What do you do?
Well, the number is you guys all have a calculator? If you
Can you, wait, you can put this up
this one?
on the inside, the 1 minus 5, can you put that on top first?
Before, you're going to do exponent first before you subtract. You got to do the 5 to the 10 first. And then take 1 minus that. You should be getting like a big negative.
Yeah.
You should be getting this on the top. Right? And then when you times it by 1, it's not going to change at all.
That's disgusting.
Divided by negative 4.
Thanks, Mark, I just said that.
So then we should get 4. Yeah. You didn't get that? That's true.
It's okay, I don't mind getting one.
Calculator is just gone.
Oh, we're doing theta for sigma. So.
Oh, I didn't have that. Oh, that's fine. I can add them all up after. That's it. I mean, as long as you understand what you did, treat it. Alright, last part of this with sigma, and you guys will definitely get a sigma question. They're really big. Okay. So with sigma notation, sigma means the sum of, and you guys had to have a starting number, an ending number, and a formula. The bottom part is always your starting number. The ending number is on the top. And when you guys do your substitution, you want to make sure you're going from 1 to 5 in here when you sub in. So where I see a K, I'm going to start by putting a 1 in the top. So it'll look like this. Do you guys remember what operation goes between them? Addition. Adding, yep. Okay. So once you guys plug a 1 in, what's going to come next? 2, good. Good job. 2 squared plus 2. Right? 3 squared plus 2. No. And then we have 5 squared plus 2. Alright, so make sure again, PEMDAS is going on in here. Exponent first, and then you can add. So
yeah, no. I
you know, when you guys add all those together, you know,
65.
you have 65?
Yeah.
And that's the 65? Okay. Great. Okay, so here our answer would be 65. Now, let's say in the front of this, if you guys saw like a 2 in the front, what would we have to do with the 65 and the 2? Multiply them. You guys remember that? So if there was a 2 in the front, we would take 2 times 65, and that would give us 130. Okay, cool. Now this would be a tough one. I think that you guys could get something like this because they haven't put it on in a while. Where you're making your own sigma notation. Now in a sigma notation, you guys always have to have a start, you have to have an end, and you have to have a formula. So sigma notation means we need this little sign, and we need our start, we need an end, and we need a formula part for this part. Okay. Well, how do we figure out a formula for this? What's going on in here? Well, wait. If you're timing by 2, wouldn't 14 times 2 be 28?
No, you're adding 7.
Adding 7. Okay, good. So think about this. You are adding 7 in here. What formula do you guys know that expresses like adding? Arithmetic. Good job. So your arithmetic sequence formula is going to help us come up with the formula part for sigma. So your arithmetic sequence is a sub 1 plus n minus 1 times d. Let's fill in some stuff. What's your a sub 1? Good. And then now your n. If we're making a formula, what do you keep n? N. Nice. And what was the d? 7. Great. Okay. So 7's are going to cancel, so we just get 7n. Now this is going to be your formula part. And it's going to kind of help us with what's going on in here. Now, people kind of get stuck with this, right? Make sure it makes sense. So what you want to think is, what you're starting with, what times 7 will give us 7? 1. Good, Frida. Okay. Now, if you want to try it out, if you put a 2 in here, we get 14. If you put a 3 in here, we get 21. A 4 in here will give us 28. What do I have to put in for n to get 105? Try it out.
Yeah, 15.
15 works? So if you did 7 times 15, you got 105? Good job. All right. So that means to get the 105, though, we got to end at 15 up here. Okay. Right. I know.
Is that, what is this?
This
is going to be a part 2?
This was a part 2 question when I saw it come up. It's making your own sigmatization, that's what it's called, like coming up your own sigma, right? Just be careful you're not putting 105 in here because you see it's the last one. That's the number that you got at the end. So you want to figure out what you had to get, sub in to get 105. Yeah. Oh, you don't need the formula part. Yeah, if you don't want to. It's just to kind of make sure you guys knew that you needed a formula in the beginning. You always need to start and end and then a formula.
So in order to get that formula, you need to do this.
Yeah, you have to do it. Yeah. I mean, unless you're someone who's really good at like coming up with them by yourself. I mean, some people are good and they can just kind of look and make up the formula based on with a pattern. But this will always work for anything. Especially because some of them will get a little bit more, I think, tougher than these kind of easier ones to figure out what's going on. All right, last one. And this is something that kind of gave you guys some issues because you forget about it. It doesn't come up a lot, but when it does, it's a little tricky. The recursive sequence. You need this one? Oh. Right. Recursive was always that you were using the previous term. And I'm going to show all the substitutions, but once you guys get the pattern, it's not bad. I feel like you just always forgot where to go with it. Yeah, there's a lot. Okay. So here we want the first 5 terms. Okay. And when you guys get recursive sequences, they always give you a starting one and they give you a formula. Right. Make sure in the formula a sub n equals. Right. You'll see an n minus 1 in there. But this part right here represents the recursive. Like what makes it recursive. So if we start this out, we know that a sub 1 equals -4. Now, if you wanted to find the second term, that's going to be like your a sub 2. So, in your formula, if you were finding a sub 2, where you found n, what would you plug in its spot? 2. Good. So you're doing the second term, so n would be 2. Okay, so what I'm going to do is where I see an n here, I'm going to plug a 2 in its spot. Okay, and then I will plus 5. Yes. Yep, exactly, Andrew. Now, in here, this little 2 minus 1 becomes a sub 1. Right? So this is where we're going to look what happened before, previous in our problem. What is a sub 1? What did we know it was? Good, Lil. They tell you a sub 1 is -4. So we're going to take -4 and plug it in here. So it really becomes -4 plus 5, which is what? 1. Good. Good. So the second term is 1. Now, if you want to find the third term, we're going to do the same thing.
Can't you just go on?
Yes. If you get this pattern that's going on, right, where you're subbing, you can just keep going, right? So it's going to be, well, okay, if you're going to do a sub 3, right, that means that where you see the n, you have to put a 3. So it's like a sub 3 minus 1, then plus 5. Just make sure you reduce this part, though. What is 3 minus 1, really? 2. So what's a sub 2? What did you figure out that a sub 2 was? 1. Good. So you're going to take this 1, plug it into this spot. So it's like 1 plus 5, which is 6. Good. And again, once you guys get the idea, like for your fourth one, we're taking that 6 Alright, so it's going to be 6 plus 5, which is
11.
11.
16.
There you go, good. And that means the 5, we take the 11 plus 5, which will give us 16. Good job, everybody.